Student, today we are going to see what is interference. Under the interference, superposition, coherent source and Young's double slit experiment. These are the concepts we are going to discuss. Okay. See here, when the two light source as a coherent source, we will get the interference. When the two lights is getting overlap, we can call it is interference. So see, before going to the interference, we should know what is superposition principle, what is coherent source. Then only we can go with the Young's double slit experiment, how the two lights is going to get overlapped. First we will learn what is superposition principle. So superposition principle, when the one or more wave or two or three waves it's overlapping together, we can call it is superposition principle. See, one wave like this, the another wave also like this with the same phase. The output we can call it is a maximum. So which is going to be constructive. So output we are going to call it's a bright. Okay. So the one wave like this, the another wave will be opposite to this wave. We can call destructive. We will get as a dark. We won't get nothing. It's called zero intensity. Okay, when the two light is getting overlapped with the same phase, we can call bright intensity. When the two wave which overlapping with the opposite phase, which is going to be 180 degree phase difference. Okay, when the light is like this, we can call it's a 180 degree phase difference. When the two light is overlapping with 180 degree phase difference, that time we can call output as a dark, which is going to be called as a destructive. Okay, there are two concepts, one is a constructive, another one is a destructive. When the superposition two or more wave overlapping each other, when the in phase will be the same, means that time we will get bright light. When the phase will be opposite, we will get as the dark light. Okay, that is called superposition principle. The another thing, what is called coherent source. Okay, so coherent source, in case imagine two light I switched on the same timing. Okay, one light is produced like this, the another light even micrometer difference also is there, means it will be produced like this. Even both is a red, it have this different phase. Okay, so which is we are not going to call as a coherent source. Coherent source means which is going to be a same phase with each other, same timing also should be there, same phase also should be there. Okay, same wavelength, same amplitude, same frequency, everything will be the same, which is going to call as a coherent source. So coherent source which is not going to available with the two different source. Okay, coherent source we are going to take it as a from single source, that is explained by Young's double slit experiment. Okay, Young's double slit experiment is required coherent source. Coherent source meaning when the light is in the same phase and the same frequency, same amplitude, that is the time we can call it is called coherent source. Okay, when you are trying to switch on in the same time also, even micrometer difference, microsecond difference will be there, that going to create as a phase difference. Okay, so coherent source will get from the single source, that only Young's double slit experiment is going to represent. Okay, so now the second thing also it's going over its coherent source, the light which is going to be a phase, same amplitude and same frequency, we are going to call it is a coherent source. Okay, under Young's double slit experiment, we are going to see bright fringes, dark fringes, it is a fringe width, angular fringe width and graph. These are the topics we are going to discuss. Okay, if you like my channel, please subscribe. Okay, now we are going to discuss Young's double slit experiment. It's meaning the topic itself, it's telling we have double slit. Okay, so from single source we are going to bring us a two different light, which is going to call us a Young's double slit experiment. Okay, see here I am taken one slit. Slit means some small fine narrow hole is there. Okay, here light is there. Okay, so here source is there. From the source I am going to get as a spherical wavefront, crust, trough, crust, trough, crust, trough, like that it's going to come. Okay, here I have two slit, S1, S2, two slit with very small distance. Okay, the distance between the two slit I am taken as a small d. This distance I am going to take it as a small d. Okay, here I have the screen. Okay, so from slit 1, crust, then trough. So crust trough means which is representing as a transverse wave, crust trough, crust trough. Here regular line is representing crust, dotted line is representing as a trough. Okay, see here, first one crust, from here then trough, crust, trough, crust, trough, crust, trough. So it is going to call us a transverse wave. Okay, crust, trough, crust, trough. Okay, so here also green color I am representing as a another slit. Okay, crust, trough, crust, trough. Sorry, dotted line it's trough, regular line it's a crust. Okay, so here I am going to get as the light fringes. Okay, so now we'll see how the fringes is formed. Okay, when we are getting as a coherent source from two different slit, okay, two light is going to create as a single source. I am taken as two different light which is going to call as a coherent source. S1 and S2, here it's a coherent source which is going to overlap each other. Finally I am going to get image on the screen. Okay, when we are getting image on the screen, where and all crust and trough, where and all regular line and regular crust, it's getting overlapped means I'll get as a bright. Okay, where the crust and trough, up, crust means up, trough means down. Okay, when this going to overlap, I'm going to get as a dark. Okay, when trough is overlapping, I'm going to get as a bright. Okay, so I'll repeat again, when like this kind of wave, okay, crust is overlapping means I'll get as a bright. Okay, trough overlapping means I'll get as a bright. Okay, when crust and trough, it's when it's overlapping like this, opposite phase, one is up, another one is down, the output will be dark. Okay, see here, at center all bright is going to overlap, which is going to get, see, I think here will be the center. All bright is going to overlap, center is the bright. Okay, where dotted line and this line is overlapping, it's going to be dark. So bright, dark, which is going to produce as the fringes, bright, dark, bright, dark, bright. Fringes means this will become as a uniform wave. Okay, see here, again I'll explain. So we have single slit here we have double slit here we have the screen. Okay, so from here one light is going to come, from here one light is going to come, from here one light is going to come. It is S1, it is S2, it's a point of P. Okay, it is called screen. Center of the screen is going to formed, it's a bright because it's going to overlap all the light, it will be crust and crust. Okay, here it's going to be dark because crust and trough. Okay, bright, dark, like that will go. Okay, now we'll come for the equation. Okay, the fringes is formed, so bright and dark it's formed. Okay, now S1 S2 is called small d, which is going to call as a distance between the two slit. Okay, capital D, which one we are going to call distance between the slit and the screen. Okay, now one wave from here, the difference between these two we can call path difference. S1P minus S2P, which is going to be called as a path difference. This difference only perpendicular line which is going to represent as the path difference. This difference S2D only, it's called path difference. S2D, this difference we are going to call is a path difference. Okay, I hope you understand what is path difference. The difference between these two wave, it is called path difference. Okay, when the path difference exactly lambda, now here I am going to get as a bright wave. Okay, I don't know what it is, xn distance, I don't know what it is, wherever it is. Okay, the point I am taken as a P. Okay, this is the point of P. When exactly one wave is formed means here it's going to be bright. Two waves is formed, bright. Three waves is formed, bright. Okay, in case off wave is formed, off wave like this is formed. Okay, here it's going to be dark because the phase difference is 180 degree. Okay, otherwise 1.5 it's formed, it's going to be dark. Okay, otherwise 2.5 it's going to be dark. Okay, when your bright and dark is going to depend on the what is the path difference is there. S2D is called path difference. Okay, now I am going to do with the equation. See, slit 1, we have two slits. Here we have the point, we don't know what it is, bright or dark. Okay, from here it is S2, it is called S1, and this is the point D. Okay, and this is a small d, and this is a capital D. Okay, from center it is O, and this is the distance of xn. Okay, and this is the from here I am taken, this is a theta angle, and this also theta angle. Okay, so in another video I will try to put this two theta will be equal. Otherwise, when the sine theta will be equal to approximately equal to tan theta. Okay, this two equal when the angle is small. Okay, sine theta is equal to tan theta. This two approximately equal when the theta is very small. Okay, that time you can take it as a this two equal. That concept also we are going to use here. Okay, now already we know S2P minus S1P. S2P minus S1P, which is going to be called as S2D. Okay, which is going to be called as S2D, path difference between the two waves. Okay, now I am going to take it as a sine theta. See here, sine theta. From this small triangle I am taken as a sine theta. Sine theta I am taken in a triangle S1, S2, D. S1, S2, D. Sine theta. Sine theta means opposite by hypotenuse. Okay, sine theta is equal to, here opposite is, it is a path difference S2D. Hypotenuse is small d. Okay, so opposite is S2D, hypotenuse is small d. I got what is sine theta. In another hand, I am doing as a tan theta. So triangle I am taken from here, this one, this one. This will take it as a point of x. Okay, XOP. XOP. The point XOP. Triangle I am taken XOP. Okay, tan theta is equal to opposite by adjacent. In this triangle, opposite is xn, adjacent is capital D. It is xn divided by capital T, which is going to be called tan theta. Okay, so sine theta is equal to tan theta when the angle is small. Okay, sine theta is equal to, it's approximately equal to tan theta. That means this two equation is equal. Okay, when this two equation is equal, you can write, so equation 1 and equation 2 will be equal. Okay, so S2D divided by small d is equal to xn divided by capital D. I will repeat again, S2D is called path difference. Okay, S2D, which is called path difference. Small d is the distance between the two slits. Okay, this is called path difference, and it is called distance between the two slit. It is called distance from the center. Xn is the distance from the center. Okay, and capital D is the distance between the slit and screen. Slit and screen. Capital D is the distance between the slit and screen. This is what we know already. Okay, now S2D is equal to xn small d divided by capital D. This is what we know. Okay, now I am going to do with the bright fringes. Okay, for bright, when the light is bright, the path difference, the difference between the two light will be lambda. Okay, the difference between two light will be lambda. Here full wave is formed. Okay, otherwise full wave, otherwise two full wave, three full wave should be formed. Then only it is constructive. Okay, so n lambda I am taken. Lambda will be one wave. Okay, so n lambda means it's how many number is there you want, you can make it, because it is a bright fringes xn small d divided by capital D. Now xn is equal to, xn means from center to the point P distance. This is the xn. The from center to point P, it is called xn. Now xn distance is it is n lambda capital D divided by small d. Okay, just I am doing as a cross multiplication. Now it is formed as a bright fringes. Okay, in case dark fringes is formed. So dark fringes is formed, what will be the equation? So just a small thing, see, full wave or next full wave, next full wave, next full wave. This formed as a bright fringes. Okay, now half of the wave 0.5, 1.5, 2.5, 3.5, like that it's going to produce as a dark fringes. Okay, so the same equation, this is the same equation I am taken, S2D xn small d by capital D. This difference will be it is 1.5, 2.5, 3.5, like that wave is formed means it's destructive, which is going to be produced as a zero intensity. It's going to be called dark. Okay, so 2n minus 1 lambda divided by 2 is equal to xn small d divided by capital D. How I got this equation? When n is 1, okay, 2 minus 1, it's going to be 2 minus 1, it's going to be 1 divided by 2 off. Okay, when n is equal to 2, it is 4 minus 1, 3 divided by 2, 1.5. Okay, 0.5, then 1.5. N is equal to 3, 6 minus 1, 5 divided by 2, which is going to be 2.5. N is 3, 6 minus 1, 5 divided by 2. N is 4, 8 minus 1, 7 divided by 2, it's called 3.5. So, like that will go when this kind of thing is going to happen, which is going to be called as a destructive, the answer will be dark fringes. Okay, so we got dark also. Okay, so as already said, under the Young's double slit, bright fringes, dark fringes we found. Okay, then angular fringe width. Okay, what is angular fringe width? That only I am going to explain. Then fringe width, then only angular fringe width. Okay, first I am going to explain with the fringe width. Okay, so here fringes is formed. Okay, center will be bright, then dark, then bright, then dark, then bright, even intensity, it's formed with even intensity, then bright, then dark, then bright, then dark, like that is formed. Okay, center will be bright, dark, bright, dark, bright. So this is going to be bright, center will be bright, dark, bright, then dark, bright, then dark, like that is formed. Okay, so see here, in between two bright, center will be one dark will be there, dark color will be there. There is dark means nothing. Okay, so bright, one dark will be there. Okay, this thickness only I am going to find. This thickness I am taken as a beta. Okay, this thickness I am taken as a beta. In between two bright, one dark will be there. So now I am taken as a bright equation. Okay, what is bright equation? So bright equation, n lambda is equal to xn small d divided by capital D. This is called bright equation. Okay, so now it is called nth fringes. Okay, nth, this I am taken from center is a xn. Okay, so then this xn plus 1, this is xn plus 1, this is xn. Okay, so xn is equal to n lambda capital D divided by small d. Okay, the next bright, in between one dark is there. Next bright, xn plus 1, n plus 1 lambda capital D divided by small d. Okay, we have two bright. It is if it is a fifth bright, means this is sixth bright, like that we are taken. Okay, so in between two bright, one dark will be there. That dark thickness only I am going to find it. Okay, so when we are subtracting two bright, in between one dark thickness we can get. Okay, so that only I am going to do it here. Okay, when I am subtracting with two bright, center dark I can get. So x n plus 1 minus xn. So nth fringes n plus 1. So this two when I am doing, so n plus 1, it is lambda capital D divided by small d minus lambda capital D divided by small d. When I am subtracting with two bright, I will get dark thickness, that is called fringe width, that is called beta also. Beta is equal to this I am taken inside n lambda capital D divided by small d plus lambda capital D divided by small d, it is minus n lambda capital D divided by small d. This getting cancelled. So fringe width is going to be lambda capital D divided by small d. Okay, the thickness of bright or dark will be lambda capital D divided by small d. It is called fringe width. The thickness of fringes. Okay, so which is called thickness of fringes. Okay, how the fringes is formed? The center, exactly center will be bright. The intensity will be maximum at center, bright. Then dark is formed. Dark is here. Then again one bright. So intensity will be like this. Then dark. Then dark is formed. This is formed on the screen. This is called fringes. Then bright. It is graph will go up. The intensity will be maximum at bright. Okay, minimum at dark. I hope you understand. From center is a bright. Then dark, bright, then dark, then bright. Uniform intensity will be there. Okay, the graph distribution will be intensity versus distance. Okay, xn distance. Okay, so it is center will be bright, then dark, bright, dark, bright, dark. Left side also same thing, dark, bright, dark, bright, dark, bright. Okay, this is completely 0 and this is maximum. Okay, the uniformity will be there, the uniform thickness distribution will be there. Okay, beta is equal to, already we found the thickness of fringe width will be lambda, it is a wavelength, capital D is the distance between slit and screen, small d is the distance between the two slit. Okay, now angular fringe width. Angular fringe width we can take it as a theta. Okay, so angular fringe width, which is going to be called as a theta. See here how the theta will be. Already we know the equation sin theta. See here the same equation only I am going to take it, tan theta. Okay, tan theta is equal to opposite by adjacent, so xn divided by capital D, which already we know. Okay, so theta is equal to xn divided by capital D. So xn also we know it is n lambda capital D divided by small d divided by capital D, this getting cancelled. So angle of nth fringe, I don't know what fringe, from center it is theta of nth fringe. Okay, so n lambda divided by small d. Okay, now I am doing angular fringe width, it is nth fringe. The next thing, n plus 1th fringe, next fringes. Okay, so which is going to be theta n plus 1. This angle is nth fringe, it is n plus 1th fringe. Okay, so it's going to be n plus 1 lambda divided by small d. Okay, when we are doing subtraction of this, we will get angular fringe width, the angle of this. Okay, the angular fringe width, angular distribution. Okay, see here, this is center, it is theta of n, and this is theta of n plus 1. Okay, so whatever bright or dark, so we want this. Okay, just theta is equal to theta n plus 1 minus theta n is equal to n plus 1 lambda divided by small d minus lambda divided by small d, n lambda divided by small d. Okay, theta is equal to n lambda divided by small d plus lambda divided by small d minus n lambda divided by small d, getting cancelled. So angular fringe width is equal to lambda divided by small d. So angular fringe width also we found. Okay, the next thing, only one thing I am going to explain. See here, when the monochromatic light we used, okay, in case orange color we used orange, dark, orange, dark, orange, dark, like that will be formed as the fringes. Okay, instead of monochromatic light we used white light. Okay, so fringes will be colored, WebGR color will be produced, VIBGYOR. So the fringes will be here, bright place will get VIBGYOR, then dark VIBGYOR, dark. So colored fringes will be formed when replacing monochromatic to the polychromatic. Okay, if you like my channel, please subscribe. Thank you for watching my video. My next video will be the diffraction. So this totally I made as a playlist for wave optics. So if you want full chapter for wave optics, please go and see my playlist. Okay, thank you for watching my video.